All right. Today's topic is wave velocity. Okay. And just as its name says, all right, obviously with velocity, we already talked about velocity about a month ago, right? And so we said that velocity, no, Donovan, don't say anything. Janie, velocity is what? What is velocity? You don't got to give me the exact definition. Just what is it? You really don't remember that word either? Dang. Eric, what's velocity? Oh my gosh, come on guys. You all know what velocity is. If you don't, then we got to go back and redo that one again. And I don't want to redo that again.
Speed and direction.
All right, speed and direction, right? But the key word here is speed. Okay? So wave velocity, damn, I better write it down. I thought I didn't have to write the definition down. Is the speed of a wave. The speed of a wave. Okay? And we talked about it the other day. That there were two different kind of waves that we were talking about the other day. One was a light wave, and the other one was a sound wave. All right, so if I could get Alondra, I know she's quick at looking things up. All right, and if I could get, who else could be quick at looking things up? Not all at once. All right, Jayla, you look up something too. Ready? Here's what I want you to do while I keep writing some other stuff down. Jayla, I want to know what is the speed of light. And then Alondra, I want to know what is the speed of sound. And if it gives it to us in miles per hour, I'm good with that. Okay? All right. Wave velocity is the speed of a wave. Okay? And like any other speed, it has a unit of measurement. The unit of measurement is going to be what? No. Because again, it's speed. Sir? M over S, which the M stands for what? Meters per second. Okay, meters over second. So it's the same unit. That's why I thought this would go a whole lot better than I thought it was. But then what it really is doing right now. Because again, velocity is something we already talked about. What do we need to get velocity?
You need mass.
No, we don't. You need distance and time. Okay, you need distance and time. But here's the issue. A wave is kind of hard, to kind of get a distance when especially it's traveling so fast that it might go right past us and we'd never even see it because it's going that fast, right? Alondra, do you have a speed of sound?
Yeah, I got 343 meters.
343
M over S.
M over S.
Mm-hmm.
Okay, so 343 meters per second. Okay, Jayla, have you found speed of light yet? What do you got?
299 million.
Hold on, 299 million. Go ahead.
792,000.
Go ahead.
458 meters over.
Okay, so as you can tell, the speed of light is a little bit quicker than the speed of sound. And when I say a little bit, I'm joking. It's a heck of a lot faster going light speed than it is going the speed of sound. Okay, 343 meters per second, all right, is the sound barrier, all right? And so what happens here is, remember the other day when I said sometimes you'll see it happen before you hear it happen? Well, the reason why is because the light waves travel to your eyes a heck of a lot faster than the sound waves will get to your ears. Okay, so that's why it gets to you. That's why you see it before you hear it. Okay, same thing. If you ever, never mind, I'll shut up. All right, so wave velocity, all right, measured in units over seconds, all right, meters over seconds, and here's our formula. So again, if you look at your reference sheet, now would be a good time to take out the reference sheet. The good news is there's only one formula for this test. So we've been having a couple of tests where you've had like a whole bunch of formulas. Well, this one you only have one, all right? It's toward the bottom, and you'll see a lowercase v with a subscript W there, all right? That's letting you know that this V stands for the same V as the other one did, velocity, but this one here has a little W letting you know that this is the velocity of a wave. All right, so that way because remember, if this were velocity straight up, we would need distance over time. But in this case, we don't need distance over time because we're not using distance and we're not using time. We are using frequency and we are using wavelength. So you see that we got some unusual looking letters there. One is a lowercase cursive or italicized F. All right, and then the other one I call the upside down Y because it looks like an upside down Y. Okay, but it's actually a representation of the Greek letter lambda. Okay, so when we look at this formula right here, what we got to do is we need to break it down. So we got V sub W. Okay, V sub W. That is your wave velocity. All right, and again, it's a velocity. So Coburn, velocity is measured in what unit of measurement? You don't have to, it's on the board.
Oh, yeah.
Meters over seconds. Okay, so it's meters over seconds. Then we've got lowercase f. All right, now notice it's a lowercase f, right? Because what did a capital F stand for earlier in the semester? Force. And what was force measured in? Newtons. Okay? But this is not a capital F, so please don't make sure, don't get them confused and don't think, oh, that's an F, that's force. No, there is a reason. I've said it since day one. There's a reason they give you capital letters. There's a reason they give you lowercase letters. In this case, the lowercase letter stands for frequency. All right? We learned it yesterday, so just to see if she was paying attention, let me ask her right now. My devil, do you remember what the unit for frequency was? We said it before we started recording. Nope, that's velocity. All right, I can already. You didn't get the cheat sheet that Coburn does. That one is not on the board. The answer to your question is not on the board. All right, Machala, do you remember the unit for frequency? Man, she said that fast. All right. Hopefully, when the guy proposes, you say the same no as fast as well. All right, Nodule, unit for frequency? Hertz. All right, it's hertz. Okay, just like some of y'all when you see your report card grade on Monday, it's going to hurt. All right, so frequency. All right, frequency is measured in hertz, Hz. Okay, as we talked about yesterday. And then again, the weird symbol, the upside down Y. Okay, first of all, this stands for wavelength. But what I want you to know also, though, is this. It is the lambda symbol. God bless you. All right, it is the lambda symbol. So I just want you to know that, all right, so that you don't wonder, like, that's some broken English that we're looking over there. Like, that symbol is a Greek symbol, okay? It is a Greek symbol for lambda, okay? And so wavelength, okay? Wavelength there should be straightforward, should not be confusing. So let me throw that one over to Eric. Wavelength, what do we measure that in? Take a guess and use common sense. That's my only clue. Sir? Meters would be correct. Okay. Why meters? Because it's a length. Length is a distance. Distance is measured in meters, right? Do you remember when we were talking about potential energy? And we said, actually, do me a favor. Go look up at the formula for potential energy, for those of you who have your reference sheet out, right? And somebody raise your hand and tell me, what was that formula for potential energy? Give me the middle one, not the one at the end. MGH, right? M stood for what? Mass. G stood for what? Gravity, and that's always 9.8. But the H stood for what? And height is measured in what? Meters, because it's a distance, right? So notice we have distance, which is an actual variable, measured in meters. We have height, which is an actual variable, measured in meters. And we also have wavelength, which is an actual variable that is also measured in meters. All right. Now, here's one of the things where you might look at this stuff like ready. For those of you now who kind of put together your units and kind of play the system, this one is going to totally destroy your hopes and dreams. Because again, meters over seconds, hertz, meters. There's no way when you do there's no way when you do hertz times meters that it makes sense that you would say my answer's in meters over seconds. Okay, so here's one that is pure memorization. Like, you have to remember velocity is meters over seconds. The good news is for an entire month you've known that. All right, but then what you also have to realize is frequency has its own thing. Like if you try to solve for frequency, you just can't say, well, it's going to be one of those two letters. You're going to be wrong. Okay, so that's what I want to make sure. Now the other good news here is this. In case some of you cannot do the calculation, there's three variables, so there is a triangle for our wave velocity. All right, Wave velocity has a triangle, and again, so if you, for those of you who are dependent on the triangle, if you look at my formula, well then my question here is, what should be at the top of the triangle? There you go, Alondra. The what? The V little w, all right? The VW, okay? The little car. F goes in this corner, lambda wavelength goes in that corner. All right, so again, if you need the pyramid, the triangle, then there it is for you. All right, so that's wave velocity. Now, we've already established the fact that light is faster than sound. That's why you see it before you hear it. It's kind of the same idea with thunder, right? You know, how many of you guys maybe you were scared of thunderstorms when you were a kid? You probably won't admit it now, but you know, all right? I mean, some of you probably even had a thunder buddy, okay? Now, the whole issue, look at my child. My child's like, what are you talking about? Okay, maybe she didn't have a thunder buddy. I think she still doesn't have any friends. But nonetheless, now I hurt her feelings. So the whole issue here with the thunder is this. Like when you were a kid and like there was a storm coming, you'd get scared because you think of the storm, you know, all that stuff. Maybe you had parents or somebody that told you, well, here's how you know, if the storm is coming or whether the storm is passing. And that is when you see the lightning and then you hear the thunder, you count. And it used to be like if you see the lightning. So let's say there's a flash. You start counting. 1, 2, 3, boom, thunder, right? Then that would usually kind of say, well, it's about 4 miles away. All right? If the number got, if your counting got less numbers, like if it went from 4, now it's 2, now it's 1, that lets you know the storm is coming. And then you would say, take shelter, right? Or go hide or find your thunder buddy. All right? And then if you started counting but the numbers were getting bigger, that means the storm is already past you and it's going away from you. Because again, the whole concept here is you're going to see the lightning flash and then you'll hear the thunder. Well, the bigger the gap, the further away. The shorter the gap, the closer it is. So that's kind of the idea there between thunder and lightning. All right. So let's go ahead and get a sample problem out of the way here for how to do this. And so let me go ahead and turn on the projector. Let me erase my goodness. Oh. All right, I want you to write this one down so that way you have a sample problem in your notes. Always good to have a sample problem, just so you can see what a problem looks like. Ooh, might need to fix that a tad. All right. So while you're writing down the question, notice I got my three-step process over here still. So again, we got the 3 steps again for partial credit. For some of you on your last test, that is literally a lifesaver because again, some of you forgot to put negatives next to your answer for like when you talk about change of heat, you forgot to put a negative next to your answer. Well, again, if that question was 5 points, you would have got them all wrong. But because again, you showed me your other 2 steps, you only maybe missed a point. So that was another good reason why your test performance was pretty good from Friday. This question says a wave with the frequency of 14.8 hertz has a wavelength of 3 meters. At what speed will this wave travel? All right. Now again, because we just finished talking for like 10 minutes about wave velocity, well, for you this would seem obvious that you're going to use the wave velocity formula. But what I want you to do is I want you to think, what if this was at the end of May? So think about it. Right now we're in the middle of March. So we got another month, middle of April. Another month, middle of May. So in 2.5 months, let's say I give you this problem. Okay? We've learned everything we got to learn. Well, then when you get this problem, some of you are going to say this because you're going to do what I taught you to do, which is what's the first thing you do in a word problem? Read the question. And what you're going to say is you're going to say, what speed, right? Well, then some of you are going to say, oh, speed. And you're going to jump to the conclusion and say, oh, I got to use V equals D over T. All right? And because some of you, I won't name names, all right, are very careless in what you do, you're not going to pay attention to 14 hertz not being a distance. You're not going to pay attention to 14 hertz not being a time. You're going to say, hey, look, I need two things. I got two numbers. What do? I divide them, and you're just going to divide it, and you're going to do your magic, and you're going to be wrong. Right? So again, please be careful. This is a velocity formula too. This can measure speed, but this needs time and distance. Do I have a time up there? How do I know? Because there is no seconds. Time is measured in seconds. There's nothing up there with seconds. So therefore, I can't use this formula. So that's why here, you don't use this formula. All right? It says at what speed will this wave? So that's why we have V for velocity, sub W for wave. That way we know this is the formula we need to use. And that's the one we're going to select. So I just want to make sure you're aware that at the end of the year, when you get one problem, you got a lot of formulas to decide from. So we're going to go V sub W, F, and lambda. Okay? So this right here, let me throw this to Alondra. VW, what am I going to put? X, all right. So we're going to put an X there. All right, Deshanti, what am I going to put next to frequency? F equals. What am I going to put next to F equals?
14 hertz.
14 hertz. All right, so we're going to put 14 hertz. All right, and then next to lambda there, George, what should I put next to? Yeah, 3 meters. All right. Coburn, what does that stand for again? I know it's lambda, but I mean, what is the lambda symbol representing? Wavelength. All right, good. I like how you went up there. I like how you had no idea. Then you said, well, there's a 3 there, so there's a 3 there, and there's a wavelength. Okay, wavelength. Okay, you can put 1 and 1 together. He just don't remember where the 1 and the 1 came from. All right, but when it's there, he knows what to do. All right. So right up here in this scenario right here, Janie, what am I going to do with those two numbers? You're going to multiply. Okay, great. So when we multiply, we take 14 times 3. We get 42. 42 what? Meters per second. Okay, meters per second. All right, and that would be your answer, unless you were in an honors class, and then your answer would be 40. Sorry, meters over seconds. When somebody say, what? Right? Remember that whole thing called significant figures? Right? 2 significant, 1 significant. My answer could only have 1. Right? But this is in an honors class. But I'm just throwing it out there. If you make me angry, I'll go back to significance, right? Because have I taught it to you? Yeah. So can I always throw it right back and say, now you're responsible for it again? Yes. So again, make me angry, make your life more complicated. All right? That's how you do that problem. Questions? Okay. I do want you to write this one down too, but this will be the last one you got to write down. Because this is making us solve for something else. So this is going to be the one where you have to decide, do I need a triangle or do I not need a triangle? The question says the speed of a wave is 65 meters per second. If the wavelength of the wave is 0.8 meters, what is the frequency of the wave? Now I'm going to do this one a little different, just to see if you're looking at the triangle or if you need the triangle. Because I know there's only one formula. But when I ask somebody what formula, I want you to rearrange the formula for me and tell me what to put underneath formula. So give me the wave velocity formula, but I want it rearranged to set for whatever we're solving for. Okay? So for that, I will give you another 10 to 15 seconds to consider. Now, remember, you got the triangle on your notes. It is not illegal to look at them today. It is illegal to look at them tomorrow, during the quiz, or during the test. For the video purposes, I should probably play the Jeopardy theme song while we have some silence. Alondra, sing the song. You can sing it with a little bit of a like mariachi twist. Huh? You don't know how to sing? that just your way of saying you can't sing? You sing badly? Gotcha. All right. What's today? Wednesday the 13th? Nodule, unfortunately, you're number 13 on my roster. Tell me the formula that I should use. Okay, but now I need you to rearrange it so that it's set for what we're solving for. Because I'll give you a clue. The formula you're looking at on your notes right now is set to solve for VW. But this problem ain't asking you to solve for VW. You don't know? Okay. Who do you think we should ask next? You got to know the answer to one of those questions. So you either tell me the rearrangement or you tell me a name. Donovan, what's the formula that I need to use here?
F equals VW over M.
Over what?
And, oh, snap. VW over that upside down Y.
Okay. You can just say lambda. All right? I got you. You're good. I was just like, what the heck is he talking about? Frequency equals VW over lambda. Okay? So again, however, though, Nodule, I'm doing this for you, but in a sense, though, I'm pretty sure there's 5 other people in the room that say, I don't know how he got that. So again, when we're using the triangle, okay, first of all, what did the question say we were solving for? So that means I'm going to cover the frequency one. Which one's the frequency? Top, left, or right? On the triangle. Left. So I'm going to cover that right there, right? So once I know I'm solving for frequency, first thing I'm going to do is I'm going to say, oh, I'm solving for frequency, F equals. Now I got to do is figure out what do I do with the other things, right? So I covered that F. What's on top? What's down below? All I got to do is write that there on the formula thing, okay? So that's how he did it. He's not a genius, even though he wants to claim to be one. All right, sorry, Donovan, sorry. All right, so now we're going to list our variables. F equals V dub and lambda, okay? So here's what I want to know right now. George, VW, what will I put? Huh? X, all right. It's not going to be X because V stands for velocity. So do you see anything up there that has velocity? That says the word velocity? Okay, sorry. Velocity is also a fancy word for speed. You see anything there that says speed? Does it have a number?
No.
You sure?
Oh, yeah.
What's the number?
65.
65, all right. So we're going to put 65 M over S right there, okay? Jasmine, what should I put next to this guy? Oop, I'm on video. Forgot. I was going to start dancing. .8. You're absolutely correct. All right, 0.8. All right, F equals, what am I putting? X. Okay. And Machala, what am I doing with those two numbers? Dividing. Which number do I type in the calculator first? Okay, that's not a number. There you go. Have you done it? Do it. Decimal what? 52. Straight up? Ain't no decimals, just straight up 52?
Yeah.
Yeah, decimal? What's the numbers after the decimal?
Did you say 52?
Then there ain't no decimal.
Why 8?
No, I asked you, is it straight up 52 or is there a number or is there a decimal And then you said there is a decimal, and I said, is there a number behind the decimal? You said, yeah. I said, what's the number? And you said, there ain't no number. And I said, what? All right. So the number is straight up 52. Okay. Machala, 52 what? Hold on, stop. Side quest what? You didn't get no 52? All right, Machala, ready? Try it again. And we got this on video. Her name is Michaela Little. Huh? 81.25. We good with that one? Yeah. All right, 81.25. Okay. 81.25. 81.25. What? That hurt. Hurts. All right. And there's your answer. Janie, if we were doing significant figures, what would your answer be? Like if we had to round your answer to significant figures, what would your answer be? All right. Not quite. Okay, hold on. I'm sorry. I didn't hear you. Nothing. What? 8. Okay, it wouldn't be 8. It would be 80. Because remember, the 0 after the 8 wouldn't count. Okay, so it'd be 80 hertz. All right, but there you go. I can see you thinking. All right, Alondra's just happy I didn't ask her. All right, any questions on this one? So we're good? All right, then. This concludes recording of this video.